We'll proceed in vector algebra and calculus. Vector algebra and calculus. As demonstrated earlier, vector is considered as the most advanced item in mathematics. It is very simple to say just add the direction to anything. If you have numerical, just add direction to it and it becomes a vector. Okay, so we gave kind of synonyms like east is I vector, west is minus I vector, j is north vector, and minus j is south vector. East, west, north, south are x-axis and y-axis. Rather, x-axis, y-axis, minus x-axis, minus y-axis. There is nothing called minus. A a minus b is actually a plus minus b. A plus minus b. A and b. Consider there are two entities. A and b, they are in same direction. A plus b. A plus b. Okay. A plus minus b. A, b minus means it will be opposite. So A plus minus B means B is in opposite direction now. Now A plus minus B hitting each other, whatever it is. There is nothing called negative. As far as mathematics is concerned, there is nothing called negative. As far as mathematics is concerned, there is nothing called division. Okay, A by B is equivalent to A into 1 by B, or a into b to the power minus 1. So there is nothing called multiplication. It is addition only. A into b to the power minus 1, nothing but b to the power minus 1 plus b to the power minus 1 plus b to the power minus 1 a times. So everything is addition only. A minus b is nothing but a plus in bracket minus b. Okay, so B, what is B minus B? Minus B is understood when you understand vector science. Vector science gives direction to any entity. Vector science, vector science gives wings to fly. Wings to fly in a sense that it has now a direction. Okay, a plus b, a plus minus b means a plus b means a and b are in same direction. I mean whatever b is, I don't know, a plus b, if b is in this direction and a is in this direction, a plus b. A plus minus b, now b reverse this direction, a plus minus b, that's it. Minus means reversing the direction, that's it. Otherwise, people consider the minus means loss. Minus means loss. Someone can think like this. If item was coming to me, it has this direction. Item change its direction. Someone can say it I'm losing because change its direction. So when we talk the science of direction, then we come into vector. What is the other use of vector? Vector one use we saw, if we calculate the cross product of two vectors, then we get the area underneath it. Only cross product. Vector has no other use. Vector has no other use. Vector has no other use as dot product. What are the operations I can apply on a vector? One is called cross product and one is called dot product. What is cross product and what is dot product? Consider that there is a wind. Consider this is x direction. Okay, I'll give another example probably. Okay, consider that there is a mass that is kept here. There is a mass there is a mass that is kept here. Hop. It is unstable. There is a mass. There is a mass that is kept here, and there is a force like this. If I apply this force on this mass starts moving. Okay, I can have different items. Okay, so this is along x-axis. If I press this, then this is moving. Okay, now consider the force I'm applying on this mass. Now, this is the mass and force is applied and it is moving in x direction. Okay, force is applied in x direction and mass is moving in x direction. Okay, not necessarily. Many things are there. When direction comes into the picture, then infinity is the limit. When direction comes into the picture, then infinity is the limit. Why infinity is the limit when direction comes into the picture? Is you have x-axis, y-axis, and z-axis. When three dimension comes into the picture, the limit is certainly the infinity. Anyway, now consider that there is a force. What is the force? Force is F. Capital F is the force. How much displacement this force is making? When force is there, then certainly it is going to make displacement. If force is there, then certainly it is going to make displacement. If it is displacing, force is capital F and it is displacing x unit. What is the work done by the force? Force into displacement is the work done. Force into displacement is the work done. Okay, so what is work done? What is force? Force can be magnetic force, electromagnetic force, gravitational pull. Okay, like if I leave this, then it comes, consider it comes 1 meter. Consider it comes 1 meter. What is the force that is applied on this multiplied by the distance is called work done. Who did this work done? Earth did this work done because Earth is has gravitational pull that is called 9.8 then 9.8 meter per second square. If this weight is 1 kilogram, then force that this generated on this is 1 9.8 Newton. 9.8 Newton. If it is going 1 meter, then 9.8 joule or something, whatever is the unit of the work done, that much energy it is generated or whatever it is. That energy came out of the earth. Earth loses that much energy because earth is doing this much work. This is the example we keep on doing. Okay, if I take a magnet, I have showed it. If I take a magnet and there is an item here, if magnet attracts it towards itself, if magnet attracts it towards itself, then there is a force applied on this mass and force is moving like this. If it has moved x unit and force is capital F through the magnet, then capital F into x, Fx joule, Fx work is done by this mass, this magnet. Okay, work is nothing but energy. Work is nothing but energy. Energy per second is the power. How much is energy applied? How much time it took? How much time it took to move? Energy. How? Okay, something called distance. If you derive the distance with the time, then it becomes velocity. That has movement. Okay, if something is moving, it has velocity. If you derive velocity with the time, if the movement what we are saying, the movement is growing, the speed is growing, then there is something called acceleration. If we multiply acceleration with the mass, then it is called force. That much force it has. If you multiply force by distance, then that much energy it is being generated. If you divide energy by second, that is the power. So if I move a mass, if I move a mass with the force capital F from 0 to x distance, then energy applied on this is F into x. If this energy applied F into x in 1 second, the power that is generated by the kind of energy source is F into xy1. If this movement happens in zero point 0.1 second, then F into x by zero point 0.1. 10 Fx is the power. So now people they talk about the displacement, people talk about velocity. The power of displacement is velocity. Okay, power of velocity is acceleration. Velocity is there, but power is high. Means it is means general term. Okay, now the power of acceleration is force. How much mass is? If mass is big and carrying that much mass, someone is accelerating, then force is high. Force into displacement, that much energy someone is liberating to move one location to another location. In how much time? If it is going in very less time only, then power is very high. That is the power. The measurement power unit is watt. How much joule is energy is burning per second? What is power of your battery? I have I have many batteries nowadays. Kind of powerhouse, kind of the battery that charges mobile or something like that. Power bank. What is the power of your power bank? 10,000 milliampere. 10,000 milliampere means 10 ampere. 10 ampere per second. 10 ampere per second. 10 ampere, I'm sorry, 10 milliampere hour. This is the measurement generally power bank carries. 10,000 milliampere hour. 10,000 milliampere hour means if you charge something for 1 hour, for 1 hour, 1 hour, this power bank, I really have a power bank and show it. Okay, nowadays everyone has a power bank. Now this is a power bank. Okay, looks like very small, but it is very powerful. Looks like very small, but indeed it is very, very powerful. Okay, it takes around 16 hours of charging. Very powerful. Okay, I have bigger power bank also. I believe I have shown it. This is indigenous power bank. Means I have made it. There are too many batteries are there, and this is a power bank. It takes around 3 days to charge. I mean, 36 hours to charge, morning to evening if I charge, or full night. 36 hours it take to charge with the normal charger. Okay, and it takes 16 hours to charge. Looks like very small. Normal power bank take around 5 hours, 6 hours only. It takes, I believe it is 10,000 milliampere hour. Means if I connect to any destination, to any mobile or something like that, for 1 hour continuous, for 1 hour continuous, it can liberate 10,000 milliampere of the current at voltage 5 volt. At voltage 5 volt. So what is the power? Power is not written here. It is written 10 milliampere, 10,000 10,000 milliampere hour. 10,000 milliampere hour, 10 ampere. For 1 hour duration, 10 ampere of the current it can liberate if the load is taking at 5 volt. So power is volt into current. 5 into 10, 50, 50, 50. What I'm sorry, what is calculated per hour basis, not per second. So 50 volt ampere, 50 volt ampere, it will generate for 1 hour. That is its watt, 50 watt. The power of this battery is 50 watt. Generally, motor comes with the power. 1 horsepower of the motor. How much power is 1 horsepower? 1 horsepower means around 746, I believe. 746 watt of power that it can generate. Okay, 746 watt. Now you can divide whatever voltage you are taking, divide, if you divide it by that much current it would liberate per hour basis. So, or that much it will take. If motor is there, that much it will absorb. So anyway, these are the measurement. Why I'm putting time in this? Because it is useful in future. Anyway, if I have an item here on x-axis and there is a force, through this force, this item is displaced x unit, then what is the work done? Work done is the force into displacement, F into x. If this force is coming from one energy source, certainly, right? If this is dropping like this, then energy source is earth that is doing the work. The work is done by the earth and it attracts it. Or consider there is a magnet and magnet is attracting an item from here to here. Magnet is doing work. That there is energy that is generated. Means magnet is losing the energy. How much it is forced into displacement. Make sense? Now consider this force is in this direction. Force is in this direction. Now consider the nature of the energy source is it pushes some item. Rather than attracting it, it is pushing it. Make sense? It is pushing it. Now consider one item is here and force is pushing it like this and it is moving one unit. It is moving x unit. Force into x. Force into x is the energy generated by that source. If force is in this direction, then will it move the item? Certainly it will move. Consider force is a wave kind of thing like magnetic field. If it is a wave kind of thing and it is in this direction, all wave are in this direction, and it is has nature that this substance, what is it made for, it will distract it. Then someone would say, then it will move in this direction. If item is kept like this and force is applied like this, then it will move item in this direction rather than in this direction. You are saying false thing. If item is kept like this and force is like this, it will move item in the force direction. That is the energy, it liberated the energy. So if item is kept like this and force is like this, then it will move this like this. Not always true. Not always true. How you can say not always true? Okay, consider there is a nut that you apply somewhere, round nut that you apply somewhere. Now I insert nut here. Okay, I used to have nut. Okay, I insert the nut here. Now this can move along this direction only. It cannot go in this direction. Make sense? Okay, I have a nut. Okay, a nut. Consider this is a nut, big nut. I really made it a nut. Now it is inside this. Okay, when force is going in this direction, it will move the nut like this. If force is going in this direction, it cannot move the nut in this because it is hanging, it will catch it here. In that sense, it will move in this direction only. Now, will it move same distance if force is capital F? Force is capital F. And consider if it is going like this and it is moving item 0 to x, again 0 to x, then how much is the work done by the force? If item is moving 0 to x, this is 0 to x distance it is moving. And force is in this direction. Force is in this direction. Item is moving in x-axis, force in somewhere. It is making angle theta with the x-axis. If it is making angle theta with the x-axis, then what is the work done? Then work done is if it is moving 0 to x, someone will say it may not move 0 to x. Consider it is moving 0 to x. It may take more time to move. If force is applied like this, then power is more. It will take less time to move 0 to x. But if force is like this, then it will take more time to move 0 to x. But it moved 0 to x. In that sense, how much is the energy applied on this mass? Okay, now consider this force is completely perpendicular to this axis in y direction. And this item is moving 0 to x. Then how much energy applied on this? Okay, if it is in same direction, then force into x. If it is making angle theta, then this force has how much force has how much its force component along x-axis is how much. Like if I take it, generally I take example of the wind. If person is standing on x-axis and wind is flowing in x-axis, he get the full wind on his body. But wind is flowing like this, then he will get less wind on his body or on his face. How much he would get? That is this wind speed cos theta. If angle is theta, wind speed cos theta. If theta is 90 degree and wind is flowing like this and person is standing like this, wind is coming exactly from the bottom, it is going up. Person will not feel any wind on his face or body, nothing. But wind is coming from front, full wind he will see. Okay, so work done is force into displacement. True, but force must be in the direction of the displacement. If force is making theta angle here, then force into cos theta. That much is the force in this direction. Okay, if theta is 45 degree, then force into 1 by a square root of 2 cos 45 degree. Force into 1 by a square root of 2 into displacement. That is the energy, that is energy liberated by the force. Okay, if I say in other way, the force, the effect of the force is decreasing. Effect of the force is decreasing. Means if I talk about energy, that is F into X, energy that is F into X, then how much energy, if consider F into X is the energy that is liberated on this. If F into X energy, okay, if force is like this, then how much energy it is liberating? How much? I believe I'm messing up. So better this way only. So if I have a force, an item is displaced in one direction, then what is the work done? Then get the force component in that direction. Then multiply by the distance. That is the work done by the force. So work done by the force is minimal. If force is in 90 degree, force is in 90 degree, then theta is 90. In that sense, what is the work done? Force into cos theta into distance. Force into cos 90 is 0. 0 into distance. Work done is 0. If that is true, then this item cannot move at all. Not possible. When work done is 0, if force is coming from below, force is coming from below, it will push it upward, but it will not move like this. So force cos theta into displacement is the work done, then cos 90 is 0, work done is 0. If this item is moving like this, still when force is at 90 degree, then some external force is coming into the picture. Because of this force, these items cannot move like this. Not possible because work done is 0. If it is making theta angle, so force cos theta, whatever is the force cos theta, that is the force that is applied on this item along the direction in which it is moving. So force cos theta into the direction. What is the direction of the movement? I axis. Force cos theta I axis. F into I into cos theta. It is more or less force vector dot product I vector. Force force vector dot product I vector. If it is moving x distance, the net work in force vector dot product xi vector. That much is the work done by the force. Someone would say that I am applying capital F force. I am applying capital F force. But work done is less because you are not applying the force in the direction of movement. That is required. If you apply your force in the direction of the movement, then only your full force will be applied as far as displacement is concerned. Okay, now I'll come back. I was saying I am confusing something. I'll come back to the same location. If I apply a force capital F in the direction of the displacement and displacement is x, then how much energy I am liberating from my body? I I am a person and there is a mass kept on the ground and I am pushing it. I am pushing it. Mass is 1 kilogram. Okay, when I am pushing it, I have a force. Force by mass is the acceleration. That much acceleration power I have. Now with that force I am moving. Force is F Newton, capital F Newton. I am moving the item along the direction I am pushing. So force into X is the energy that is liberated by me. Okay. Now, instead of pushing that item in the direction of the movement, I am pushing the item at 45 degree. Now I am pushing the item in this direction where the item is kept like this. Okay, it would move, but it will move slightly. It will move slightly because to move x distance, it need F force. If energy I keep constant, that is F into x. But if I apply F at angle theta, then the net force that is in this direction is F cos theta. Okay, F cos theta, that is small. Okay, if force is small, then F cos theta is small. F cos theta into x is not F into x. To make it, consider F into x is 100. Now, F cos theta is F into x is 100, where force is 10 and distance is 10. 100 joule of energy was liberated, that much work was done. Now, force is applied at 45 degree. The net force has come to, I believe, some 6 Newton. Net force has come to 6 Newton in the direction of movement. Now to get work done of 100 joule, I have to move that item 100 by 6. That will come as around 16, I believe. Okay, 16, I believe. So to get the same work done when force is at 45 degree, to get the same work done, I have to move it to more distance. Then only that much energy will be considered. Work done will be considered. So if you apply less force and then you move the item, you have to move the item more in comparison to if you apply more force and you move the item less distance only. The energy that will be imparted on this body is same. Okay, but you are saying that my force is, but your direction is different. Whatever it is, the energy that is going from your body to move the item, that energy is same. I believe it is understandable. How much? Okay, if I liberate 100 joule of energy, if I liberate 100 joule of energy, then I eat 100 gram of butter. Okay, if I liberate 100 joule of energy from my body, then I tend to eat 100 gram of the butter. Okay, if I am pushing the item, my force is 10 Newton and item is 1 kg and I push for 10 meter, whatever it is, 10 into 10, 100 in the same direction, then I am going and eating 100 gram of butter because that much energy I invested from my body. Now instead of pushing in the same direction, I am pushing at 45-degree angle. I am pushing at 45-degree angle. Okay, if I am pushing at 45-degree angle, then this item, then I am applying on this item. Item moved 100 meter, 10 meter only. Will I go and eat 100 gram of water? Whatever I am eating, it is proportional to how much energy I am losing from my body. Okay, in that sense, I will feel less hungry because the net energy that net force that is applied on the mass in the direction of movement is less. So to move x distance with the force at angle theta is F cos theta. That is the energy force that is actually applied on the item. Okay, and that item F cos theta, if it item is moving x distance F cos theta x, less energy is coming out of my body. Okay, but if mass is moving like this and full energy I'm applying completely vertical, then F cos theta is zero. No energy I am releasing from my body at all. Okay, as far as if I lift the item, then energy, then force and item direction is same. But item will move like this only because it is fixed. In that sense, then no energy applied. I not need not eat anything at all. Force is going completely orthogonal to the displacement. Here, the vector comes into the picture and dot product comes into the picture. Force dot displacement is force vector dot displacement vector is the net work done. Net energy applied on the force or applied on the item. Whatever energy you are carrying doesn't matter. Whatever the force you are applying doesn't matter. The energy that is applied on the body, the energy or the net work done by the body, if I consider net work done by the mass that is moving, that that work done, that energy that is liberated on the mass, this is better word. The energy that is liberated on the mass is force vector dot product with the direction of the mass. So here vector comes into the picture, direction comes into the picture, right? Direction has very big importance. Many people say teacher is teaching. Okay, so this is calculus and this is integral calculus and this and that. There is one guy, there is one student, is completely listening to what teacher is saying, what professor is saying, what lecturer is saying. He is completely listening. When lecture is over, now he learned completely. There is one more guy sitting near to him and he is making a kite with a paper. He is making the kite. Okay, when lecture is over, then he did not understand anything. Okay, now at the end of the lecture, professor saw that this guy is busy in something else. Where your mind is? Now he's asking, where your mind is? What are you thinking? Why you are not listening to me? What is happening? The professor lecture vector is this, then a student concentration vector is like that. They are perpendicular to each other. Means whatever the energy professor is liberating, that student is not absorbing at all. There is no energy he is receiving at all. He is sitting in front one. There is one other guy, his vector and professor vector is in same direction. So he is absorbing the energy. Another person who is sitting in front of him only, but his vector is orthogonal to the professor vector and he is not receiving any energy. Two people are eating same food. Please watch our video, that is why two people are eating same food and one is highly energetic and one is suffering from cancer. Two people are eating same food. Two people are eating same food. One is exuberant. What is the English word? One is kind of sensational, thrilling with energy. He's bubbling with the energy. Another person is admitted to the hospital because he is suffering from cancer. Doctor is not able to understand these two people are eating same food. One is bubbling with the energy and one person is admitted to the hospital for cancer. Understandable, right? This is the importance of vector. Now, there are scientists, there are doctors, and they are into investigation that why cancer happens. Now they go to cellular level and mitotic division, and those things they try to understand. And then they try to understand why there is a swelling happening. Not required this much, right? You are trying to understand, that is the result. You are trying to understand why that person got 0 by 100 because he could not write into the paper. He could not write into the paper because his blood reaction and this reaction not required because he could not absorb energy at all. If he could not absorb energy from the professor, then what he will write into the paper? Two people are standing in sunlight. Two people are standing in sunlight. One person has bone that is very powerful. He can run 10 kilometers in a flight. Another person, he feels highly tiredness when he walks for 10 meters also. Now, both are getting vitamin D same from the sun, but one is absorbing, one is not absorbing. This is the reason of disease. Vector is a very big thing. One is energy thrower, energy emitter, and one is energy receiver. Both has to be in same direction to get the work done. If the item who is receiving the energy, if I calculate the work done because of that item internally, I am talking about work done, work done, how much energy this energy source is losing, how much energy this energy source is losing when there is an item like this, and energy, because of energy source, this item is moving like this. How much energy this item is absorbing or work done, same thing. That is the force and move and direction. Both vector must be in same direction, then force into displacement. If force is orthogonal, then this will not get any displacement at all, because force force vector dot product with the displacement vector is the net work done. We will talk more on the work done. Work done is a very big thing. Now, there are two analogy people can think about. How much energy that energy source is losing when he is moving item one place to another place, or how much this guy is absorbing energy when he is moving one place to another place. Okay, two things. But at the end, energy lose is energy gain. If this guy is not gaining the energy, but this guy is losing the energy, this guy is not gaining the energy, this guy is losing the energy, then energy is absorbed by the medium, because he lost the energy, right? Energy emitted from his body. And another guy did not receive anything at all, zero. Then energy cannot be destroyed. Energy takes its form, changes its form. It was absorbed by the media, air, water vapor, or floor, wall of the room, whatever it is. That was absorbed. Okay, whatever it is. The work done is the force into displacement, where force is in direction of the displacement. If force is this way and displacement is this way, then what is the direction of the force along the displacement? Or what is the displacement along the force? Both are same thing. Displacement cos theta, then displacement comes in the direction of force, or force cos theta, then force comes in the direction of displacement. F vector dot displacement vector is the net work done. We will talk more on it, and then I thought of introducing calculus here. So if I move an item here 0 to x distance, then it is force is a constant k, then k into x is the work done. What about force? What about force? Consider force is in this direction only. Like there is a spring, there is a spring and there is a mass attached to it. There is a spring and there is a mass attached to it. Now I pull this mass from the spring, okay, x distance, and then I release it. Then what is the work done by the spring? Spring attracts. The force of the spring considered as k into x. The force of the spring is considered as k into x. So at the beginning, force applied at the zero location, force applied on the mass is zero. But as we move, then a stretch will be more. Makes sense, right? A spring at the beginning position, if mass is there, this is the spring, this is origin. If I pull it, then force applied by the on the mass is less. But if I go and stretch this much, then force applied on the mass is more. Consider that is kx. This depending upon the x, force is growing. Now, if I release this and it comes to still, then how much work done by the mass? If force applied is constant k and 0 to x is the distance, then k into x is the work done by the mass when he comes from x distance to 0. But force applied is variation of the distance. Again, I would say multiplication. Kx into x is the work done, not true. This is calculus we are bringing. I have a force that is x plus xi plus xj, and spring is like this, force is like this, whatever it is. Displacement is happening from 0 to x. Force is for what is the force equation, that is xi plus xi plus xj. Displacement is 0 to x. Then what is the work done by this displacement? Then what is the force in the direction of displacement? That is xi, x, x into x square. Not true. Why? Because there is a concept of dependence and independence. X-axis is considered as independent component, and force that is considered a dependent component. Dependent into independent cannot be direct multiplication. This is what we have seen. Now it will land up into integral calculus. X into x. If force is kx into x, wrong. Kx into dx. This is abstract multiplication. Kx into dx. D I have to insert, saying it is not straightforward. Then integration from 0 to x. Kx x square by 2, 0 to x. Kx square by 2 is the work done. So we will talk more on this. One thing is direction that we talked, I believe, in detail, and next is calculus. Both things are there. Direction and calculus, don't kind of mix it with the professor and son. What example I give? Someone can mix it. Who is stopping? Who is stopping anyone? Anyway, please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.